Fitness coach wants to determine whether a 4-week strength training program increases the number of push-ups a person can complete in 1 minute. A random sample of 12 participants was tested before starting the program and after completing it, and the results are shown below. So we can see that we've got 12 numbers listed here in pairs, and so I've got a before and an after for each person. Assume the differences in the number of push-ups completed are approximately normally distributed. Is there convincing evidence at the alpha equals 0.05 significance level that the training program increases, and so we're actually giving like a direction here for our hypothesis, the mean number of push-ups participants can complete in 1 minute? So this one, when we talk about what type of problem this is, we've got a matched pairs t-test going on. So this is dependent and a matched pairs. So I'm going to go ahead and come to the what type of test and what calculator function will you need. We're going to call this a matched pairs t-test, or dependent samples would also be fine. But in terms of what we're going to use for the calculator, because this is the one where we enter in an L1 and an L2 list, and then we use it to go find an L3, and we only use the L3, this will just be the regular t-test in the calculator. Okay. So what I am going to need to do in just a moment is enter both of those lists. So I'm going to grab my calculator, and we're going to hit the stat button, and under edit, it's going to pull up the list function for us. So I'm going to enter all the before numbers into L1. So 22, 18, 25, 20, 30, 24, 19, 27, 21, 23, 26, and 20. And then I'm going to go ahead and enter all the after numbers in for L2. So we have 27, 22, 28, 24, 33, 27, 23, 30, 25, 26, 29, and 24. Okay. So once you've got them all entered, you go ahead and you arrow up to where the L3 is and hit enter. And then down at the bottom, we're going to hit second and 1 to put the L1 there, minus, and then second 2 to put the L2 there. So when I hit enter, it's going to fill in the L3 for me with the difference between these numbers. So looks like all these things that are popping up here, these I see a bunch of negative numbers. What does it mean for it to be negative in this problem? They're taking this number minus this number. And so in the before, they could only do 22 push-ups. In the after, they could do 27. And so that -5 is actually an improvement. So this problem was saying, is there convincing evidence that the program increases the mean number of push-ups that they can participate? If they're increasing, it would mean that this difference is a negative number. So we need to look at that when we go to write the null and alternative hypothesis here. So they want us to write something about the differences. And so our null and alternative are going to have the mu sub d to talk about the mean of the differences. And I'm actually going to write the alternative one first. The mean, what we're asking is there convincing evidence to suggest that the program increases the mean number of push-ups? And an increase would mean that it goes from a smaller number to a bigger number, so that when you subtract these, you get a negative number. That would mean that the mean is less than 0, that we would get a negative number is what that means. So to write your null hypothesis, then we turn this around and put greater than or equal to 0, or you're allowed to just put an equal sign there if you would like. But this one has to be less than 0, because that would say that we have a smaller number first and a bigger number second, which would talk about us increasing the number of push-ups that people can do. So this is important for this problem. Okay. So this is a matched pairs t-test. So in terms of the test statistic, when I go get that from the calculator, it's going to be a t-value, and we're going to get a p from the calculator as well. All right, so going back to the calculator, we got all our lists in there now. Now I'm going to go ahead and just hit the second and stat button. Oh, sorry, not the second and stat button. We're going to just hit the stat button. Arrow over to tests, and we're just going down to number 2, the regular old t-test. This time, because we entered lists, I need to actually select data, and it's going to change the choices down here. Under the mu sub 0, our mu sub 0 has zeros for the number in there. So we're going to change this to a 0. And then for the list, mine already popped in L3. If yours doesn't have L3, you'll want to enter L3 there. For frequency, we want it to stay 1. And we don't want to keep not equal to this time. We want to use the less than for the alternative hypothesis. So I'm going to arrow over to the middle choice and then hit calculate. Okay. So when you go to look at what's going to pop in there for your p-value, we've got a very tiny p-value because this says 5.92 times 10 to the negative 10th power. So we would have to move that decimal point backwards 10 places. We're going to have a bunch of zeros in there. This is a very tiny p-value. So our test statistic, negative 18.57. Remember, the t's are very much like z-values, and we said any z-value that's more than 3 is huge. So a t-value of negative 18, that makes sense as to why we're going to get such a tiny p-value. So literally, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros before I can go ahead and put that 592 in for those other numbers. So this p-value is smaller than any alpha we could probably come up with here, but they told us that we wanted at the alpha equals 0.05 level. We've definitely got a smaller p than 0.05. So because the p-value is less than the alpha, we're going to reject the null hypothesis. So when we're talking about what our conclusion is for this one, there is sufficient evidence at the 5% level to suggest and then what did this mean? This meant that the difference in the number of push-ups was the mean difference was negative. That meant that there was an increase in the number of push-ups that we could do. So we can say there is sufficient evidence at the 5% level to suggest the program increases the number of push-ups participants can do. Okay, so the alternative hypothesis for this one is kind of confusing in terms of how you're like, well, what does that actually mean? But you'd want to go back up to what we claimed, and we claimed that the 4-week training program increases the number of push-ups a person can do. So when we are able to reject the null hypothesis, then we're able to say that claim is correct, that this program increases the number of push-ups the participants can do.